Hello, we're taking a look at the ZTest perceptual learning activity. This activity helps us to understand when we would retain a null hypothesis distribution and when we would reject it. A null hypothesis distribution is a prediction. It's a prediction of where the sample mean should end up. And right in the middle of this distribution is what we could consider ground zero. So this is where we're expecting the sample mean to be given our belief in the predictive power of this null hypothesis distribution. If the sample mean ends up far away from that ground zero, then that's telling us that the null hypothesis distribution didn't do a particularly good job in that case of making a prediction. And so if that's the case, then we would reject the null hypothesis distribution. We would say, well, it told us it should be, here, ground zero. And look, the sample mean was quite a distance away. We quantify just how accurate is a null hypothesis distribution by calculating a z-test. The z-test tells us how many standard errors the sample mean is away from where the null hypothesis distribution predicted that it should be. So a z-test of 2 again is telling us that the sample mean was 2 standard errors away from where it was predicted to be based upon the null hypothesis distribution. Now, I'm going to keep a prediction in the model that led to its prediction if it's doing a good job. So if I see a null hypothesis distribution and the sample mean is close to ground zero, I'm like, hey, it did a pretty good job. It's a keeper. On the other hand, if something's making predictions and they're wildly off, I'm like, that's not a good model. Let's scratch that model and make something else. The way that researchers decide whether the null hypothesis distribution is worthy to keep around is by looking at this z-test score, for example. If the z-test score is more than plus or minus 1.96, then they'll go ahead and reject the null. A z-test, again, is telling us how far off was the sample mean from our prediction. And if they don't match, we're going to get rid of our prediction. We're going to get rid of that null hypothesis distribution. So a big z-test, in terms of a big positive z-test, or a big negative z-test, is telling us that there wasn't a good match between the prediction made by the null hypothesis distribution and reality, or our sample mean. So anytime this z-test is either positive 1.96 or more, or negative 1.96 or less, we reject the null. If the sample mean is within this middle area of where it was predicted to be, we'll get a z-test score that is less than plus or minus 1.96. So it'll be here in the middle. A z-test of 0 would be like, wow, that sample mean ended up right where it was supposed to be. Okay, so let's apply this here. This z-test is 2.0. It's beyond the plus minus 1.96, so we're going to reject the null, and that leads us to support the research hypothesis. A z-test of negative 0.66, well, it's well within the range of what we would consider acceptable. We know, again, that all the predictions won't be smack dab right on the button. There's some messiness, if you will, in this process. So we'll go ahead and retain the null hypothesis. Z-test, negative 0.66 means, it was within plus or minus a standard error around that sample mean, around the expected population mean. Okay, so z-test of 2.1, we're going to reject the null. Z-test of negative 0.14, we'll retain it, so I'll click here on the card itself. A z-test of 1.37, retain. Z-test of 0.12, wow, the null hypothesis distribution said, expect the sample mean to be right here, right by, ground zero, and it was just a little bit above, just 0.12 standards above. So, wow, great null hypothesis distribution prediction. We're going to keep that null hypothesis. Here, the null hypothesis distribution did not lead to a good prediction. There's not a good fit, right? The z-test, negative 2.17, the bigger, the value either plus or minus, the worse the fit. So we'll go ahead and reject the null. So z-test of 0.56, we're retaining it. Z-test of negative 2.0, we'll reject. Z-test of 1.96, it's right on the line, and when it is rejected. Z-test of 1.37, we'll go ahead and retain. 2.05, we reject. Negative 0.14, we retain. 1.37, we retain. Negative 0.98, we're going to go ahead and retain. A z-test of 1.72. Well, you know, it's getting closer to the error we wouldn't, where we'd be more likely to reject it, but it didn't cross that threshold of either the negative 1.96 or the plus 1.96, so we retain. Let's see, here we go. Z-test of negative 2.0, we reject. Negative 0.26. A z-test of negative 1.96, we'll go ahead and reject the null. Negative 1.62, retain. Negative 2.6, we'll go ahead and retain the null. 1.37 is a retain. 2.6, that's a reject. 0.17, again, really good job by null hypothesis distribution, retain. Negative 2.33, we're going to reject because it is far away from where this model predicted it should be. So we're not going to keep this model, or reject it, and we'll come up with some new model, right? Some new hypothesis. All right, so in this case, the percentage correct was 83.33. Average decision time was 2.95